now that I'm not insulting any of you because you lot are not dumb. None of you would be silly enough, hopefully, to do that. I'm getting a kind of weird thing going on here. Yeah. Remember we collected data on your ages and I was going to do a thing, our last thing called the stem and leaf. So that's not right. Let's do it. There. Can you see all the data now? Good, right. So I'm going to show you how to create a stem and leaf. There are some homework questions in the last homework that deals with that. So what you do is you've got your raw data. It's all jumbled up, not very interesting the way it's written. And you draw a vertical line. And there are two versions of this. Let me show you the first version. You put 0, 1, 2, 3, 4, 5, and 6. Technically, I don't need the 0, but to me, it seems nice to have it. If you look at our data, the youngest person I've got 16, and the oldest is me at 66. So each of these digits represents the 10. So that 5 means 50s, and that 2 means 20s, and so on. And then what you do it in kind of 2 steps. So here goes. 25, 22, 17, 19, 19 again, 34, 25, 20, 23, 17, 19, 18, 16, 30, 17, 17, 16, 16, and finally 66. Did you see how, I mean, I zoomed through that really quickly, but do you see how I transferred the data from the raw data to this thing? This is called the stem and leaf diagram. And then down at the bottom, you put a key. And what you basically do is you just tell people what this means. So 2/5 means 25. Now, the reason you do that is that, can you imagine this data was decimals, 2.5, 1.6, 1.6, things like that? Then you would put the key 2/5 means 2.5, right? It would look exactly the same. No decimal points ever appear in these, right? You just basically are doing it. So you might say, well, it's a little bit more organized, but you said it would be in 2 stages. And so here's stage number, the final stage. And I'll put in 0. I'll put in 1, 2, 3, 4, 5, and finally 6. And I've got 16, another 2 16s. 1, 2, 3, 4 17s. And 1, 2, 3 19s. So I basically just put them in order, right? If you're really good, you can do both those stages at once. But yeah, I'm old, I'm not good. I have to do it kind of the quick way, and then I fix it. And hopefully I fix it anyway. So this one's going to be 20, that's the 0. 1, 2, 1, 3, and 2 5s. And then I've got 30 and a 34, nobody, and a 66. And then I'll put down here that 2/5 means 25. And you probably should have a heading. And the heading here is ages of people in math 146. Now it's orientated a little bit strangely. So if I do this and I add in a little pretend rectangles, can you see a histogram? Right, so I know it's not great data because there wasn't a lot of it. It'd be nicer if we had more and more numbers, we'd see the pattern. But if you were a gambling person, what shape do you think this data is?
Skewed to the right.
Yeah, I would say skewed to the right. Do you think this data has an outlier? And that outlier would be me, right, at 66. So can we answer questions like the shape of the data, if it's got a shape that has a name to it at least, and if it's got any outliers? Now, stem and leaf diagrams are pretty easy. Would you agree? It's pretty quick to set them up, right? As long as they're not too many numbers. But one of the problems I can see with this data is that there are really only 4 rectangles. Would you agree there's not a lot of detail in it? So sometimes what you will do is you'll do a refined version. And the refined version looks very similar, but it has one major difference. You don't have a single 0, you have 2 zeros. Oh, by the way, do you know what the 0 would be? If I had a 9-year-old in our class, wouldn't I put a 9 here? Or a 5-year-old, I'd put a 5 here. If somebody brought their baby, a 1-year-old, right? That's what that would be. Now, back to this, you do 2 zeros, 2 1s, 2 2s, 2 3s, 2 4s. And do you notice, even if nobody is in that age group, you still put, you know, like the 40s and the 50s, right? You still put them there. Now, what does this do? Well, now that you've got 2 1s, the first one is going to be for 10, 11, 12, 13, and 14s. And the second one is where you put the 15, the 16, the 17, the 18, and the 19. Do you see that you broke the 10s into the first half of the 10s and the second half of the 10s, the early 20s and the later 20s, right? The early 50s and the later 50s. So I could actually just do it from scratch, but since I've got, here we go, since I've got my data in order here, I'm just going to use that to do it. Right, so what do I have? I have, well, actually, don't all of these teams belong to this group? So 16, 16, 16, yeah. 17, 17, 4 of them, and 3 19s. Now, what about in the 20s? Well, that's 20 goes here, that's 22 goes here, and that 23 goes here. But don't the 25s belong in the second group, right? 25, 26, 27. Right, you go to the next one, I got a 30 and a 34, and then here I'm 66. Does the 66 go in the first one, or does it go in the second one? It goes in the second one. Now, as Murphy's Law would have it, it didn't do that much difference, but it did kind of stretch out the data a little bit. That's just an idiosyncrasy of this class. Wouldn't it have been nicer if we'd some 14s in this class? We could have, you know, went this way a little bit. Or if we had a 37, it could have strung it out. So when you're looking at your stem and leaf, there are 2 versions. There's a single digit stem, and there's a break it into 2s stem. And that's it. Are we good? And that's pretty much it. We've looked at all the different types. So now we're going to go and start looking at how does WebAssign homeworks look. Okay, I've been getting some emails from various people in various classes, so it may not affect this class. But if you're still not sure how to join WebAssign and where your homework is and a few bits and pieces like that, I'm going to finish a little bit earlier, like 5 minutes earlier, and I want to just talk to you and take you through it, because maybe you missed it because you weren't here on the first day, or you don't know where to look or so on. So if you've got any issues like that and you want to be doubly sure, you know, where's my homework, how do I join WebAssign, do that. So here we have a 5-figure number summary. Remember the 5 figures? And this here is 90 male students, and this one is self-identified female students. And this is the fastest that they've ever driven. Wow. Now, I'm just going to look at the naming of these guys first. I think I'll use it in red. What they call the extremes. The little guy is the minimum, and the big guy is the maximum. Does that make sense? That 50, right? So one of the students, one of those male students, they went and said to you, what's the fastest you've ever driven? And they've said 50 miles an hour. Some people lie, right? They also lie at 147. I think you need a sports car to do 147 going down a hill, but maybe they were exaggerating. But we'll assume that they're telling the truth. Now, the quartiles. This one is Q1, and this one is Q3, and the median is obviously the median, but isn't the median sometimes called Q2? So do you see the 5-figure summary is there? They've just called it extremes, quartiles, and median, right? And if you look at the women here, they are over there. So the questions are really pretty straightforward, at least in this question. What's the fastest speed driven by anyone? Well, if you look at the maximum for the males and the maximum for the females, would you agree that the answer here would just be 147? So we're just looking, do you know how to understand, look at this and glean out the information. Now, the slowest speed driven by a male means you only look at here, and the slowest maximum speed was 50 miles an hour, which I still am quite dubious about. The speed for which 1/4 of the women had driven at that speed or faster. Now, that's one of the quartiles. And it's either that one or it's that one. And you have to be careful with the English language. It's 1/4 of them, right, or faster. So which one of those two numbers for the women corresponds to the number at which they'd done that speed or faster? And it was 1/4 of the women that did that.
92.
Great, it's the 92. Now, if they would wanted me to answer the 83, wouldn't they have said what speed did what speed did women do? So, well, I'll rephrase it. The speed for which 1/4 of the women had driven that speed or slower, then that would have been the 83, wouldn't it? I mean, all I need to do is change or slower, and that would give you the first quarter. Or faster is like the big guys, right? Oh, little guys, big guys. Now, then goes on and says the proportion. That word is important. So the proportion of female drivers who had driven 88 miles an hour or faster. Now, do you see 88 is right in the middle? So isn't that basically half the females? So when you see the word proportion, they are looking for a fraction or a decimal. I hope WebAssign will accept either of those two answers. Suppose I gave you this question. What proportion of males, right, had done 96 miles an hour or slower?
25.
Agreed? 25. Here's a sneaky one. What proportion of males had done 118 miles or slower?
75.
Agreed? Right. If you think of your little box plot thing, right, that's its shape. That's where 1/4 of the day is. That's where the next 1/4 is. That's where the next one, and that's one with the last. So when you have questions that ask you to tell you all of that number, some of them might just ask you for that number. So remember, there's two sides to this line. It might be the 25 side, it might be the 75 side. But since it's a proportion, you put that number in. You could just not notice the word proportion, and in which case you could end up writing a number down rather than that, or you could write a percentage down, which would be different. Are we comfortable about these tables and how you can read off the information? Right. So here is another one. And this is the heights in inches of self-identified females. Right. Would you, well, let's just ask the questions. What's the height in inches? What's the median height in inches for women? Nice baby question to start today. Median height of women.
65.5. I think that's what it says.
It is. Isn't that question so simple you could talk yourself out of the answer? Right? It's just simply, I know where to look. Now, there's a word here that we haven't got to, so it's a good time to talk about it. What range in heights in inches That is the difference between the shortest and the tallest of these students. So they're telling you this guy called range. Well, if you take the tallest one, she was 72, and you subtract the shorter one, she was 58, that's the range. And that's going to be what, I believe that's 14. Which actually isn't that big a range. I think if you got a whole load of women or men, and you'd probably get more than a foot difference, I would suspect. Now, the next one. What is the interval of height in inches containing the shortest 1/4 of these students? So I need a start number up to a finish number that's going to have the shortest 1/4.
58 to 63.6.
Okay, do you see? You start at the extreme, right? The minimum, right? The smallest woman is 58. Gotcha. And they want the first, the shortest 1/4, want it to be 63.6 in, right? The Q1 mark. What is the interval of heights that's contain the middle 1/2 of students? The middle 1/2, which would be basically there, right? What's the start and the finish for the middle 50%, the middle half of student data?
63.6 to 67.8.
Does that make sense, everyone? It would be here to here. That would be Q2, right? Sorry, Q1. And that would be Q3. There's the median, Q2 in the middle. Yeah. If I went and asked you, what range would the top 50% of students be in? Right, the tallest 50% of women. What would the range be for that?
65.5 to 72.
So there to there. Are we good? Right. So here's a question where they've given you a histogram. It's weird what they ask people. This figure contains information about, I believe, 140 college women, and they asked them how many ear piercings they have. I guess that makes sense. Don't you have ear piercings, and sometimes you have double ear piercings, so you can put 2 earrings in at once? I guess that's it. But I'm really worried about anyone who would have that number there. Wouldn't that be 13 ear piercings? Oh God, that must look ugly. I hope no one in this class has got that, because I apologize if I just insulted you. Sometimes I blurt things out. Can you imagine 13 ear? That would be your whole ear. Oh God, that makes me shiver. Well, evidently one of them had it. So some people like piercings. Right, back to the question now. Describe the shape of this data. And remember, you have to be pretty generous when you talk about shapes. Nothing's perfect. And sometimes it helps me to do that. I just basically put a little, I make a hill out of it, and that helps me. Come on, it's one of these three.
Skewed to the right.
Agreed? Would you agree this is more right-handed orientated? Now, is it a perfect one? No. Are you a little bit worried about that bump? Yes. But you're going to go for it, right? It's roughly. I guess they should have said roughly in front of all of them, shouldn't they, to be fair? Because they did say roughly symmetric. I think they should have said roughly skew to the right and roughly skew to the left, since that's the only choices. Does this shape have an outlier?
Yes.
Yeah. The person with 13 ear piercings. I guess it must be my generation. I don't have ear piercings. I've never had ear piercings. I don't have tattoos. I'm a pretty boring person, aren't I? But everyone, the world would be a really boring place if we all liked and wanted the same things in it. They're really boring. So it's good that people like tattoos and ear piercings. Just not me. Now, this one here says the figure below, this histogram, summarizes the responses given by 124 college students to the question asking them how much sleep they had the previous night. Well, I definitely don't want to be those students. Based on that scale, that's probably 2 different students, isn't it? It's probably a little bit more than one, so it'd be 2. So 2 students only slept for 2 hours. That one there's, I don't know why you would sleep for 11 hours. Well, you know, I've had nephews. Anybody got nephews or brothers or sisters who like sleep forever? I mean, they just stay in bed all day if you'd let them, right? Is that you, Mark, or are you going to commit to a brother or something?
A little bit of both.
Okay. So everyone is different. So here is our basic histogram. It does tell us quite a lot of information. I'm going to ask some of my questions slightly out of order. Does this data look like it has an outlier? No. So that would be the answer that goes there, right? Now, describe the shape of this data. And you've got left, you've got symmetric, or you've got right. And because they wanted to, they've now stuck in highly skewed to the left and right and approximately symmetric. And I think they did that for a good reason. If I do my little hill thing, that shape, well, you tell me, because I know what the answer is.
Symmetric.
Yeah. And the fact that you put in a roughly, or in this case, approximately, the reason they put highly in, if something is going to be highly skewed to the right, right, it better be really noticeable, right? Not kind of, it's sort of skewed to the right, I'm not 100% sure, or I want to stick the word approximately in front of it, if, you know, that would be the difference. Now, since there aren't any outliers, I don't fill that box in. Explain why you think this value is an outlier. Well, since I don't think it's an outlier, I would leave that blank as well. So question B, that no means the rest is ignored, so, which seems a little, you feel that you should always fill things in, don't you? It's like forms, even if all you fill in is NA, right? You feel that, you know, forms should be filled, but in this case, you just leave it blank. Now, this question, what was the most frequently reported number of hours that someone slept?
7.
Well, you agree it's right there. And roughly, how many students said that they slept for 8? Oh God, this is bad for me. Oh, God in Himmel. My eyesight's not great. I'm going to go 18. See if I do that and it says no, won't I go 17? If it says no, won't I go 19? Since I've got 5 guesses, I'm probably going to nail it eventually. Right? Are we good with that question? If I show you a rectangle, can't you ask all sorts of stuff like that? What's the range in ages? I know they didn't ask it, but let's do it. Well, the range is the difference between the most and the least. So the range here would be 9 hours if they'd asked it. They might have asked, what's the most number of hours someone slept? You'd say 11. What was the least? You'd say 2. Can you imagine? There's other questions they could have asked, but they didn't. Any questions? Or are we good so far?
Oh, I was just going to say there should have been more students on the 2 and 3 hours ones, because I feel like that's what students do. They don't sleep very much.
Well, that's probably true. Okay, I'll tell you a joke connected to that. When jokes come into my head, I just have to tell you. This Scottish professor back in Scotland was getting really annoyed at his students. So we're doing what Ian says. They were sleeping for about 2 or 3 hours. So we're getting drunk the night before, coming in at 4 in the morning, turning up to lectures half asleep, and he was getting really fed up. And he decided he was going to try and use it as a teaching moment. So the students are all in class, half asleep, and he comes in and he brings a big jar of worms and he puts it on the table. He brings out a bottle of whiskey and he bangs it down next to it. And the students waking up and they start looking at the whiskey because it got them interested. And he says, look at this. And he points at the worms and they're all wriggling around. And he says, look at this. And he shows them a bottle of whiskey. And he says, watch. He takes it and he pours the whiskey into the big glass jar that the worms are in. And the worms wiggle and wiggle and wiggle. And then after about 5 minutes, they're all dead. And the students are fascinated by this. They're all actually paying attention and they're watching. And at the end, he went and said, okay, everyone, what does this prove? And one of the students puts his hand up and he says, well, it tells me if I drink a lot of whiskey, I'll never have worms. God, that joke died. That's a good joke. Daniel, is that a good joke?
I was expecting like to say something along the lines of, well, if you swim in whiskey,
I think unfortunately your audio was broken up there, but I'm going to pretend you said something nice about my jokes and how funny they were. And you also said everyone else who didn't laugh has no sense of humor, right? So that's what he said if you didn't catch everyone. Agreed, Autumn?
Sorry.
Yeah, I was gonna say that was a pretty smart move on the student. He was thinking like 10 steps ahead.
He was thinking outside the box. Okay, hopefully we're good. Right, hopefully you are now saying question 5 from the homework. Is that correct? I want you to say something. We are good, okay. Now maybe I can make this a little bit bigger. This is a different class, but it's a ear-piercing kind of story. And let's look at this one. Would you agree that this data is still roughly skewed to the right? Okay. Are there any outliers in this class? I definitely think 13 is an outlier. Would I count 0 piercings as an outlier in this data set? No. Would you agree having one little gap's not enough? Would you agree you have to have a noticeable separation? Since there are an outlier, which was it? And in this case, the number was 13. And explain why you think it's an outlier. Well, it is close to the bulk of data. There are no outliers. It is separate from the bulk of data. I would probably use that one. And then it goes on and asks the usual. In this case, it's only 2. And roughly how many? I'm going to go for 46, but it's a rough, it might be 47. And roughly how many women said they had 4? I'm going to say 32, but it might be 31 or 33. For the most part, would you agree these are pretty straightforward questions, right? There aren't any tricks. There aren't actually really any calculations either. We'll do lots of calculations, but that will be in the future. Covered that one. Now, I'm going to have to shrink this a little bit. This data summarizes the diastolic blood pressure for a sample of 700 women in the age group 30 to 39. Diastolic blood pressure is the second of the 2 values in a blood pressure measurement. Now, I know when I get my blood pressure checked, which is actually quite a lot because of my health issues, I always get 2. I can never remember what's a good number, but evidently you get one number and then you get another number, and one of them's a little number and the other's like 170 or 190 or something, right? And I was told by a student once, who does in the nursing program. Isn't it something to do with the pressure of the blood going in and the pressure in the blood coming out or something? Something to do with the heart and the blood pressure pumping process. Not that you need that for this question, but this data has been grouped. So you've got 45 to 55 and then 55 to 65. Now, one of the things that's not clear when it's written in this format is what do you do about someone whose number is 55? I mean, you can't count them twice. Would you agree that's not fair, right? I call that double dipping, where you count one number in two different locations. The convention is you count the first number. So this is actually 45 up to and not including 55. So this would be 45 up to 54.99. Imagine they got a really accurate blood pressure measuring thing, right? So this would be 45 up to, but not including 55. This would be 55 up to, but not including 65. So the first number you count and the last number in the pair, it's anything just as close as you like to it, but not it, right? So a blood pressure is 74.999 would be in this group, but the minute you hit 75 or 75.001, you'd be in this group. Okay, so does the grouping kind of make sense now? What do you do with the boundary? You give it to one of the groups based on the rule I just said. Now it says here, create a histogram. Now, when you have group data like this, do you notice that you give the start number and the finish number? So this would be 45 to 55, and then it goes up the way. But when you look at this histograms here, do you see it's not giving you the raw data? Isn't it giving you the percentages? Now, if you wanted to do this by hand, which you can certainly do, wouldn't you find out what percentage 85 is out of 700? And then you'd find out what percentage 73 is out of 700. And then once you had these percentages, wouldn't you look at which one of these four looked right? But there's a little guy here called use salt. So I'm going to hit that one. I'm going to bring it over here. And can you see that it's already got the data, right? And I want to draw, it was a histogram, wasn't it, I believe? So charts and graphs. Go over here, tell it the data. And here is the data as a frequency. There is the relative frequency. So click on that dot and recalculate. Now, the only thing that's a little bit awkward here is, do you see that these are decimals, but aren't they the same as 35%, 30%, and so on? So what does the picture look like? Let's see. Well, it kind of climbs up. I may have to shrink it a little bit. That's a pain in the butt. Here we go. Shrink it twice. Good grief, how many shrinks do I need to do to see the whole thing? There, finally got it. Would you agree it kind of basically is symmetric or very, very slightly skewed to the right? So keep that picture in your head and then go and look. For those who've got visual memory, is it picture number 2, which is that one? Or was it picture number 3? I see a finger. Oh, I hear 3, or I see 3. Right. Do you notice how that's higher than this one? You see that guy? I'll bring the other one back for a second. Can you see it higher? So it's now changed to 2. Are we cool on that? So I don't actually need to do all the work. I hit salt button and it will tell me what the thing looks like. And then I look at the 4 choices and I do it. And then you have a couple of provide a summary of this data set. Right, so looking at the histogram, which is this one here, they give us 5 descriptions, and you read through them and you pick the one that you think describes this picture the best. And then you go to this one and you do the same, but I'm not going to go into that. Do you recognize this picture or this thing, whatever you want to call it? Isn't a stem and leaf, right? Now, I can't do this on the screen, but I can do it physically. If you turn your head to the right-hand side, can't you see the histogram it would make? Or maybe you're just good at looking at an orientation. What shape has this data got?
Symmetric.
Would you all agree it's roughly symmetric? I like the word roughly. Now, it says, what's the highest temperature in this data set? Well, isn't it 94? Now, how do I know it is 94? Because blinking better be 9/4 means 94. And since it's temperatures, I'm pretty sure it is 94, right? I don't think it would be 9.4, right? That would be a very strange place, right? Because I'd be freezing all the time. Now, the lowest temperature would be 62. And then it asks us, what percentage of these 20 cities have a mean August temperature in the 80s? Well, when I look at the 80s, do you see it's one of those double split versions? So what does that add up to? 4? Isn't that 5 of them? Well, 5 out of 20 is 25%. Boom. If you are given the data in this format, isn't it just as good, but better probably, than me just writing down the 20 numbers in a big wrong list? If I did that, wouldn't it be much more difficult to tell shape and who's the biggest and who's the smallest and what percentage are in the 80s and so on? And here you get to build your first stem and leaf. And you have to be flexible. And here we are looking at a whole set of data, right? There it is there. And it says, draw a stem and leaf. I guess I wouldn't call that word draw, I would call it make, but whatever. Draw a stem and leaf of this data. The stem represents hundreds and the leaf tens. So 230 would go in that box or in that box. Where would you put 230? The top one or the one below it?
Top.
Top. So I'm going to put 230 there. Enter. Did I mention how I'm going to do it? I think I'll just put a space. I think that's how I'm going to do it. Maybe let's check. Yeah, there we are, separated by spaces, right? So that's what I'm going to do. Why won't that highlight? There we go. Now, after 230, I do 30. Where does 30 go?
First one.
Yeah. That's what 30 looks like. And then 50.
Second box.
Did you all catch that deliberate mistake? It was actually just a mistake. And so on and so forth. Then they throw in some curveballs. 14. Wait a minute. You can't get 14. That means I'm going to have to round off my data to the nearest 10. So won't 14 count as 10? Right. In which case, won't it be a 0? What about the number 4? That's a curveball. What would 4 round off to the nearest 10? And I put a 0 there. I should be putting 1. That's because I'm thinking in the next question. What would 4 be if you rounded it off to the nearest 10? 0. Right. People sometimes get, we're good with that. If you round 4 off to the nearest 10, you get 0 and 0 goes there. Right. And this one catches people out. What does 135 round off to?
140.
140. And if you are 140, where do you go?
The third box.
Now, can we pretend for a minute, and I'm just randomly putting digits, well, not that digit, randomly putting digits in. Like that, okay? Putting that one's a double hitting the button. Although that would be for me, that would be the first pass, right? Wouldn't you then put them in order? So you're not finished until the stem and leaf is in order. Okay, are we comfortable about that's what your stem and leaf should end up looking like when you're finished? Now, once that stem and leaf is drawn, if you imagine it being rotated, won't it look like one of these histograms? I have no idea what it is, so let's pretend it's that one, right? And then if it was that one, just for argument's sake, if it was that one, wouldn't you call that skewed to the right? If it was that one instead, let's pretend that actually the data looked like that one, wouldn't you say skewed to the left? I don't think I've got any symmetric here, right? Would you agree the choices look to be two that are skewed to the right and the other two are more skewed to the left? And there's your choices. Now, can you see we have another set of data? And this time it's not the double split. You remember the one where there are 2 zeros and 2 ones? Can you see this time it's just going to be a single split? Won't that be a lot easier to do, right? So 55, right, would go here, 57 would go here, 59 would go here, 82 would go here, 85 would go here, and you would create your guy. Now, if you have a stem and leaf, shouldn't you be able to do one of these dot plots from it? Shouldn't you be able to use this guy to help you draw that guy? And again, I don't know which one it is, so it's that. Is everything kind of got a reasonable flow to it? There's no real, okay, maybe there was an awkwardness with some of that data, you know, the ones where you had to round it off. But apart from that, it's been pretty straightforward, I would hope. Yeah, we're good. That's it. Say your last name. I went and asked people who are not sure about the homework or web assign to hang about. So that's what I'm going to do for the next 5 minutes. The rest of you are just going to say your last name, and I shall see you tomorrow where we will finish this section off. And that will be us covered for what we need to do for our homework assignments.
In 10 minutes.
In your case, yes, I'll see you in 10 minutes, David. Okay, bye-bye, guys. Apart from those who, as I say, want to find out about how to do and how to set up homework. Okay, Mark, you having issues with the homework, how you set it up yet? No, I don't think so.
I mean, I'm good at doing the homework. My only issue is I'm still using the free access code because I ordered a code from the OC bookstore.
Yeah.
Like over a week ago, but I haven't gotten an update. So I'm just kind of letting you know that I'm still getting my code.
Right.
But I'm able to do the homework for now, no problem.
Right. It's a 2 week, is it? It should tell you when it's going to expire, won't it?
Yeah, I still have like 11 days.
Okay, so I would think they'll see if they get on top of it. I mean, if they're posting it to you, did you ask them over the phone and then they say we'll post it out? Is that what's going to happen?
No, I ordered online and paid for like 2-day shipping. And like I said, it's been a week. I did try calling them and I left a message like 2 days ago and they still haven't gotten back to me. So I was planning on just going in on Monday, maybe if they haven't gotten to me by Friday, just going in person and ask.
Right. I know that the college has been closed because of the bad weather, and then the bad weather may have buggered up the mailing process. But you know, it's a long time to wait. But you've got a good window, so I think you'll be safe.
Just wanted to let you know, just in case it doesn't come in on time and my stuff expires.
Yeah, I'll just fire you from the class and just drop you in. You know, find somebody else instead to take your place. Okay.
Okay. Sounds like a plan.
Okay.
All
Right. Erin, Bryce, Michelle, and Michaela. Michaela, you definitely want some help, don't you?
Yes.
Right. So all of you just watch this, not just Michaela. I'm going to take me a few seconds to find it. Oh, darn it, in space. Right. Hold on a second, everyone. I'm going to have to go in and find the right. There we go. So here we go. So what you can do is you go to Canvas and you click on the stats our class and hit how to enroll in WebAssign. Now, WebAssign is where all our homework and everything else is stored. It's not Olympic College, it's not Alex, it's a totally different thing. So you go to the you can do it in more than one way. You can go to the bookstore and buy your code from them. So you don't need to buy a book. You don't need to buy anything physical. You just buy this code. You can also go to WebAssign's site, right? Just look it up, WebAssign. Here it is here, right? And I'll click on that. Click. There we go. Right, and then what you can do here, well, that's probably a bad choice, but what you can do is go to students and get started. And I have a class key. You see that? So if you bought one, you would click on it. If not, you can buy one directly online from them instead, which seems to be a little bit less trouble. So let's suppose I have a class key, right? So the class key is this guy. So I'll copy it and put it in here.
We can't see.
You can't see that? Oh, okay. Let me go out and again. Sometimes when you change a page, it stops you seeing. Okay. Right. Did you see the Canvas site before I clicked on the WebAssign link? Right. Right. See this guy here? This was in Canvas. Let me go back out and show you, because I'm not sure what you didn't see the first time round. So you will be in Canvas. You will get this site. You'll hit how to enroll in WebAssign here. And you can then click on that one. And that will take you to here. And you'll do students. I have a class key. And you will type in my class key. And you enroll. And there I am. And you will hit continue, but I better not do continue or else I'll end up as a student and that will screw up my whole data set. And when you're in there, you will get 2 weeks free to, you know, without having to pay any money. But you will be asked, probably at the beginning, I haven't done this for a while, do you want to buy I think they'll call it a code, a class code from us. I wish they wouldn't use words that sound so similar. And what that is you basically buy it and you pay for it. And that's you in for good. You're in for the entire quarter and you will get things like the ebook. So you don't need to buy a book. And off you go and do your thing. Does that make sense?
Yeah.
Right. So that's how you're going to get into WebAssign. Once you're into WebAssign, that's where all your homework is. That's where your class tests are going to be. That's all, you know, pretty much everything. If you don't have, because financial aid's been slow or whatever, and you don't have the cash with you right now, you do have 2 weeks where you can just go in and use the free access. And you'll be able to do everything that everyone else does. But at the end of that 2 weeks, it's going to say, hey guys, time to pay up. How do you pay up? You can type in a class code, not a class key, a class code. That's something you bought. You can buy a class code off the college. It's basically, do you know one of those cards you get, gift cards that you scratch off and there's some numbers underneath it? It kind of looks like that. And so you'll just type in 1288779 or whatever yours is and you're paid. Or you can just do it on the site and click on I will pay it, put in your credit card details, and boom, you're done. I wish I could remember how much it's going to cost. I know it's pretty expensive, but so are textbooks. And I believe it's over $100. And I apologize for that, but I don't have control over prices. Okay, is there any other questions connected with how do I get into WebAssign? Hopefully you all get into Canvas and look at the resources there. And pretty much everything I've said is there somewhere, including when you get into WebAssign, it will tell you what homework is due, and you just click on it. And just like we did today, see those questions we did today at the end? They were straight out the homework, and that's kind of what it looks like, and that's how you answer them.
I have a question.
Yes, Sarah.
So for those people who are added late, like yesterday, will we be docked for attendance like for Monday, Tuesday, and Wednesday because we didn't show up?
That's a good question. I haven't thought about it. I'll have to think about that. You weren't here, so you weren't participating. So my thought is that you probably will lose those days because you weren't here. But I might think of a way around that. If you watch the videos for the days that you missed and contact me by email, I'll ask you a question about each video, and that'll be evidence to me that you really did see it, and I'll probably give you the attendance that way. I think that, now I'm thinking about it, I think that would be a fairer way of doing it. But only because you weren't here. If you miss Tuesday next week, I'm not going to have, oh, well, you can just watch the video. That would be just defeating the purpose of coming to class.
Yeah, definitely. I watched the video, so I'll email you later.
Right, and I'll ask you a question about the video, and you will then answer that question as proof that you've seen it. So I might ask you a question like, how many students were 16 years old, right? And you'd be able to go and look at the, the bit where we collected it. And, or actually one of the videos that you missed would be how many siblings they had. I may ask you a question like that.
Okay. And also, do you get docked points for attendance for not turning on your camera?
No, but I would prefer you did. It makes my life so much easier when I get feedback. But some people have internet issues, and if they turn on the camera, they don't have bandwidth. So I understand it from time to time. Sometimes you have a bad hair day and you just don't want to show people. I understand that. But I try and put the camera on. It makes my job of feedback much easier if I can see what your faces look like, because I have all your faces while I'm teaching, and that's why when I ask questions, when people nod, I can say, okay, I'm on the right page, or I know what's happening, and it makes sense to you.
Okay.
So do it if you possibly can, would be my advice, as much as possible.
Okay, got it.
Got it. Anybody else? Okay, if there